Let's talk about cross-site scripting vulnerabilities, or in other words, XSS. As we know, cross-site scripting is a type of injection attack in which web applications accept malicious scripts that are often appended to a URL or inserted into user-supplied text that is displayed to all visitors to a web page. Injection attacks are among the top security risks on the WASP top 10, with XSS a major contributor. We must check for XSS vulnerabilities when we are hired to test web application security. Cross-site scripting vulnerabilities, which have become some of the most common web application vulnerabilities, are achieved using the following attack types. It's reflected XSS, stored or persistent XSS, and the DOM-based XSS. Cross-site scripting vulnerabilities, which have become some of the most common web application vulnerabilities, are achieved using the following attack types: reflected XSS, stored persistent XSS, and the DOM-based XSS. Successful exploitation could result in installation or execution of malicious code, account compromise, session cookie hijacking, revelation or modification of local files, or site redirection. Note, the results of XSS attacks are the same regardless of the vector. You typically find XSS vulnerabilities in the following: search fields that echo a search link back to the user, HTTP headers, input fields that echo user data, error messages that return user-supplied text, hidden fields that may include user input data, applications or websites that display user-supplied data. The following example shows an XSS test that can be performed from a browser address bar. It's JavaScript alert, UMAR SXS test, or document cookie. The following example shows an XSS test that can be performed in a user input field in a web form. It's worth to noting that attackers can use obfuscation techniques in XSS attacks by encoding tags or malicious portions of the script using Unicode, so that the link or HTML content is disguised to the end user browsing the site. Let's talk about reflected XSS attacks. Reflected XSS attacks, that is non-persistent XSS attacks, occur when malicious code or scripts are injected by a vulnerable web application using any method that yields a response as part of a valid HTTP request. An example of a reflected XSS attack is a user being persuaded to follow a malicious link to a vulnerable server that injects or reflects the malicious code back to the user's browser. This causes the browser to execute the code or script. In this case, the vulnerable server is usually a known or trusted site. Note, examples of methods for delivery XSS exploits are phishing emails, messaging applications, and search engines. Here, in this figure, illustrates the steps in a reflected XSS attack. Here, let's talk about that. It's step 1. The attacker finds a vulnerability in the web server. Step 2. Attacker sends a malicious link to a victim. Step 3. The attacker clicks on the malicious link and the attack is sent to the vulnerable server. Then the attack is reflected to the victim and executed. Then the victim sends information depending on the attack to the attacker. Also, you can practice XSS scenarios with WebGoat. It's the vulnerable website You can easily test the reflected XSS attacks by using the following link. But as we talk it in our practice lessons, we exploiting XSS attacks in the Portswigger training labs. Yes, but also you can use WebGuard. Stored XSS attacks. Stored or persistent XSS attacks occur when a malicious code or script is permanently stored on a vulnerable or malicious server using a database. These attackers are typically carried out on websites, hosting blog posts, comment forms, web forms, and the other permanent storage methods. An example of a stored XSS attack is a user requesting the stored information from the vulnerable or malicious server, which causes the injection of the requested malicious script into the victim's browser. In this type of attack, the vulnerable server is usually a known or trusted site. In the figure here, we can see the XSS attack. Also in DVA, it shows that the user has entered the string in the second form field in the DVA here as a message. After the user clicks the Sign Guest Book button, the dialog box shown in this figure appears. The attack persists because even if the user navigates out of the page and returns to that same page, the dialog box continues to pop up. In this example, the dialog box message is Omar was here. However, in a real attack, an attacker might present users with text persuading from them to perform a specific action, such as your password has expired or please log in again. The goal of the attacker would be to redirect the user to another site to steal his or her credentials when the user tries to change the password or once again log in to the fake application. The document object model is a cross-platform and a language independent application programming interface that treats an HTML, XHTML, or XML documents as a tree structure. DOM-based attacks are reflected XSS attacks that are triggered by sending a link with inputs that are reflected to the web browser. In DOM-based XSS attacks, the payload is never sent to the server. Instead, the payload is only processed by the web client or browser. In a DOM-based XSS attack, the attacker sends a malicious URL to the victim, and after the victim clicks on the link, the attacker may load a malicious website or a site that has a vulnerable DOM root handler. After the vulnerable site is rendered by the browser, the payload executes the attack in the user's context on that site. One of the effects of any type of XSS attack is that the victim typically does not realize that an attack has taken place. One tip about the DOM-based applications. DOM-based applications use global variables to manage client-side information. Often, developers create unsecured applications that put sensitive information in the DOM, for example, tokens, public profile URLs, private URLs for information access, cross-domain auth values, and even other credentials as variables. It is a best practice to avoid storing any sensitive information in the DOM when building web applications. Also here, let's talk about the XSS evasion technique.